Hello, good day. Welcome back to another math video. This day we'll be talking about trigonometric ratios. This is a continuation of our first video about trig ratios, but this time we'll be talking about how to compute for the side length of a triangle, the angle measurement, and we'll be talking about special triangles. So first, we're going to talk about how to solve for the length of the sides of a right triangle using trigonometric ratios. So example 1, a given triangle ABC, we are asked to find the length of side A. So to do that, angle A is 36.37 degrees, angle B 53.13, and of course our angle C is a right angle. Our hypotenuse is C, which is 5 units, and again we are looking for the length of side A. We need to remember first the concepts about the 6 trig ratios, namely the Sohcahtoa-Choshakov. So recall that sine is obtained by dividing the opposite side by the hypotenuse, cosine, adjacent over hypotenuse, and the rest. Going back to our example, angle A is the opposite side of our side A, and of course that will be our hypotenuse. So based from this given information, what trig ratio can be used? We have the opposite side, we have the hypotenuse side. Good. We can make use of our sine ratio. And look at this one. With respect to our B, side A is our adjacent side, and that will be our hypotenuse side. Going back to our 6 trig ratios, what is the appropriate ratio to use? Good. So we can make use of our cosine. Now, what does it tell us? It means that we can actually make use of the sine ratio and the cosine ratio, and we will end up with the same answer. Now remember, we are doing some approximations here, so basically our final answer might have a point discrepancy. Should I say 0.01, a difference? So we'll see that one later. So for this example, we'll be utilizing both the cosine and the sine ratio, just to show that we can use either of the two. So let's start with the sine. So sine A is equal to the opposite over the hypotenuse. That will give us, again, A over 5. And we know that our sine A, the angle A, measures 36.37. So we'll substitute that one in our formula or equation, and that will give us sine 36.37 is equal to A over 5. And then we'll have to do cross multiply. And then using our calculator, that will give us this one. So side A, using the sine ratio, that is approximately 2.96. We'll try to check. So we have sine of the angle 36.37 multiplied by 5, and that gives us approximately 2.96. So let's have the cosine ratio. We'll try to see whether we can have 2.96 or close to 2.96. So again, substitute our angle B equals 53.13 degrees, and that will become A over 5. Again, using our calculator, we'll have cosine of 53.13 multiplied by 5. That will give us, let's try to see, that should give us cosine of the angle 53.13 multiplied by 5, that should give us approximately 3 units. Again, as I said earlier, we're doing approximation, so basically there is a point difference. No? Not that much, but there will be a point difference. Again, we are doing approximations. Now, question, which one is correct? Both are correct. Okay, you can make use of either the sine or the cosine ratio. So again, both are correct. So that is our example 1. Example 2. So given triangle ABC, find the length of side B. So this time we are looking for the length of our side B. And again, we'll be using our 6 trig ratios. With respect to A, B is our adjacent side. That will be our hypotenuse side. So which trig ratio to use? We have the adjacent over the hypotenuse. That will give us, correct, the cosine ratio. Angle B, that will be our opposite side. Hypotenuse side, what trig ratio? Good, sine ratio. So we'll plug those information in our formula, and we'll have this. So again, the same thing, we'll be using the two trig ratios, and again, this is just for a presentation, no? But in your solution, in your quizzes, in your task, you can actually make use of, it's up to you, the cosine or the sine or the tangent. Again, those are all correct. Cosine of A, 36.37, that is b over 5, and that will give us approximately 4.03 units. Sine of B, that will give us sine of 53.13 is equal to b over 5, cross multiply, approximately that will give us 4. So again, there's a point difference because again, we are doing approximations. I hope that is clear to everyone. Next, we're gonna talk about angle measurements. So earlier, we made use of our trig ratios to solve for the length of the missing sides of our right triangle. So what if you are given the side length and then we are asked to find the approximated values in degree of our angles? So how do we do that? First, so example number 3. Given triangle ABC, find the measurement, the angle measurement of angle A. So we are given a triangle ABC, and then B is equal to 4, C is equal to 5, and then we are asked to solve for angle A. So as usual, we'll be using our trig ratios, but there is a twist. So we'll see that one later. So since we are looking for angle A, look at our given information. Angle A, that is the adjacent side, that is the hypotenuse side. Now, look at again our trig ratios. Which of the 6 we'll be using? We have the adjacent, we have the hypotenuse. We can make use of the cosine or the inverse, which is the secant. So we'll try to set up our equation. Cosine of A is equal to the adjacent side over the hypotenuse side, which is equal to 4 over 5. Then cosine of A is equal to 4 over 5. So how to solve this one? We don't have the value of our A. Basically, that is our task, to solve for angle A. So how to do this? Now, this is where our calculators will come in handy. In our calculator, there is actually a function there that will help us to solve for the missing angle value of a triangle. Let me just explain this one in a bit. So basically, in our calculator, there is a function there that will, it's called an inverse of the trig ratios. I want us to look at this one, this part. Above sine, we can actually see here, I hope you are seeing this one, the sine exponent -1, or the inverse of sine. Cosine, above it, we have the cosine -1, and then tangent -1. Those are the inverse of our trig ratios. This is the function that we'll be using if we are looking for the angle measurement of a triangle using the sides. So basically what we're doing is we are trying to reverse the process. Earlier we are given the angle and we are looking for the sides. This time we are given the sides, we are looking for the angle. So we can we'll be using this function. Now how to call this function? In our calculator again, functions are in color. So everything that is in color red can be obtained by pressing first the alpha. Look at the alpha, that's red. So click on alpha and then click on this, you should have A. I hope you are seeing that one. Again, everything that is in red will be called by pressing first the alpha button. And as you can see, everything that is in, I don't know what's that shade, yellow shade, can be called using the shift button. So for instance, in our example, we have cosine of A and then 45. So to do that, what we'll be doing is this. A is equal to the inverse of cosine 4 over 5. And that should give us the angle measurement. Of course, approximated value. So let's try to do that. To call this function, click first shift cosine and then write the fraction or the ratio. We have 4 over 5 and then close parentheses, enter or equal sign. That should give us 36.89 approximately. So So that will be the value of our cosine A. So that will be our cosine of A. I hope that is clear to everyone. So if you do have questions, write them down in our comment section down below. Next, another example. Given triangle ABC, find the measurement of angle A. So the same thing. With respect to angle A, that will be our adjacent side, the opposite side. So which trig ratio to use? Okay, good. So we'll be using the tangent. You can pause this video if you want to solve this one for yourself, or you can simply follow along with the solution. Okay, so we have tangent of A, opposite over adjacent, 6 over 7. So the same thing. We're going to have, my mistake, that should be a tangent of A. That should be tangent of A. Then we have this. So again, in our calculator, we'll write shift tan 6 over 7. Close it with a parenthesis, equal sign. That should give us 40.60 approximately. So that will be our approximated value of our angle. I hope that is clear to everyone. If you are new to this channel, please do not forget to give this video a thumbs up. And also, if you want, you can click the subscribe button and also click the notification bell for more updates. Okay, so we'll proceed to the third part of this video, the special triangles. So example number 6. Given triangle ABC, find the measurement of side C. Yan. So basically, upon looking at the equation, upon looking at the illustration, we can make use of trig ratio, or we can simply make use of our Pythagorean theorem. But then again, in this example, I will be using the trig ratios to deliver a point, because these are special cases, the special triangles, the 45-90 triangle, the 30-60 right triangle. So we're going to talk about that now as we proceed with this example. Again, to solve for C, look at our given. We have the opposite and we have the hypotenuse. Basically, the two sides are congruent because, again, the angle measurements are congruent, 45 and 45. So we're going to have, sine 45, that will give us 7 over C. Sine 45 times C is equal to 7, and that should give us C is equal to 7 over sine 45, or 7 square root of 2. So that will be our answer. In triangle like this, we can actually make use of our trig ratios to solve for the side length, or we can simply do it mentally, of course using a formula. Now if you are dealing 45, 45, 90 triangles, we can actually make use of this concept. So a 45, 45, 90 triangle is a right triangle with two 45-degree angles, and the hypotenuse is the square root of 2 times longer than the either leg. So example earlier, that is our legs, 7 and 7. So the hypotenuse should be equal to 7 times the square root of 2. That is why in our answer earlier, we have 7 times the square root of 2. So example, our length is, this is 5, this is 5, and this is 5. Basically, our C will be equal to 5 square root of 2. So that will be the shortcut, no? That is why it's called special triangles, because there's no need for us to write lengthy solutions for this. So all we have to do is the hypotenuse is equal to the side length times the square root of 2. So again, example, this is 5, this is 5, C will be 5 square root of 2. If this is 3, this is 3, C will be 3 times the square root of 2. So that is for 45, 45, 90 triangles. Example 7. Given triangle ABC, find the measurement of side C. Now notice this time we're dealing with 30, 60, 90 triangle. So how to solve for this one? So basically, I will be using trig ratios, and sine B is equal to opposite over hypotenuse, 5 over c. That will give us sine of 30 degrees, 5 over c, cross multiply, and then c is equal to 5 divided by sine of the 30 degrees, and that should give us 10. So what is the rule when we are dealing with 30, 60, 90 triangle? Same with our 45, 45, 90. Here's the catch. So a 30, 60, 90 triangle is a right triangle with 30-degree angle and 60-degree angle. The hypotenuse is twice as long as the shortest leg. So in this example, our shortest leg is 5. So basically, our hypotenuse is twice. So 5 times 2, that will give us 10. And we can actually see that one in our example earlier. C is equal to 10. And then, the longer leg is the square root of 3 times the shorter leg. The longer leg is the square root of 3 times the shorter leg. What is our shorter leg? That is 5. Times the square root of 3, that will give us 5 square root of 3. You can actually check this one using tangent. Tangent of A. Tangent of A is equal to the opposite over the adjacent. So, kindly check on that if you want to verify this answer. But then again, this is how we get the values of our 30, 60 triangles. The hypotenuse is times 2, twice the shorter leg, and the longer leg is the shorter leg times square root of 3. So in summary, this is it. 45, 45, 90 degrees. Again, we said earlier that the hypotenuse of the 45, 45, 90 triangles, that is the length times the square root of 2. Yan. So we have x square root of 2. And then in our 30, 60 triangles, the hypotenuse is twice the shorter leg, and the longer leg is the shorter leg times the square root of 3. So I hope you have learned something from this tutorial. Again, please do subscribe for more videos like this, and also kindly click on that notification bell for more updates. If you do have questions and clarifications, please do not hesitate to write them down in our comment section.